All right. Try again. I don't think it's going to have audio again, but I'll get that fixed. Share my screen. Let's do entire screen. Oh, you guys can hear me? Let's get started. I'm going to navigate over to Rhino. So let's open up Rhino. Last week we went over laser cutting. And did we go over 3D printing? No? Okay, so we're going to do a quick run through of 3D printing. You should have already watched the lecture on 3D printing, so I don't have to go over it slowly. And then we'll also do a demo on the CNC. And then if we have time, we'll start dividing into our groups today and start fabricating stuff. So let's do... All right. Sure. All right. So we have our 3 coasters here in Rhino. I've got my laser cut one on the left, 3D printed one in the middle, and then my CNC one on the right. We're going to focus on the 3D printed one. So I'm going to select that coaster and I'm going to type in export. Alternatively, you can go to File, Export Selected, and just do that. Okay. As I go to insert this file, this exported file into my folders, I'm going to look for the correct folder. I'm going to go to Assignments. I'm going to go to Coasters. I'm going to go to 3D Print, and I'm going to leave it here. I'll name it. Today's date, 25/07/01. This is a coaster, and then I'll put my initials, and I'm exporting it as an STL. If you guys are taking notes, write that down. STL. Okay, and what it stands for is stereolithography. So we're going to export that as an STL, and then I'm going to save it right there and click OK and OK. All right. The next thing I'm going to do is I'm going to slice it to 2 different slicers. The reason for that is we have 2 different laser cutters here at school, at least here in our department and in Makerspace. We have Bambu P1S 3D printers and Ultimaker Curas. With the Ultimakers, I have an S5 and I have an Ultimaker 3. Okay, so those are the 3 3D printer models that we're going to use is P1S, Ultimaker S5, and Ultimaker 3. Now, the reason why I want to show you how to slice for either one is because there's a limited amount of each printer. Okay, there are only 4 Bambu P1S printers here in our architecture department. There are only 4 P1S printers in the Makerspace. And then there's only maybe anywhere from 3 to 6 Ultimakers in the Makerspace, counting the S5s and the 3s. Now, the Bambus are super popular, and I highly recommend that when you're in the 3D printing group and you're having to 3D print, go for the P1S right off the bat. Don't even try the Ultimaker. The difference is incredible. The same coaster of mine took an hour and a half to 3D print on the Ultimakers in the Makerspace on either one. With the P1S, it took 30 minutes. So way faster results, way more satisfaction. You get to see your 3D print right away. The issue with it being so great is that it's so popular. So as we're using those printers, there might be other students from my other class coming in here and trying to hop on those P1Ss. So you need to be ready to adjust and be flexible, and you might have to slice for a different 3D printer. Okay, slicing is the term. We're taking our STL file from Rhino, and we are slicing it in either Ultimaker Cura or in Bambu Studio. And then after we slice it in either one of those, then we're sending it to the correct 3D printers. All right, so let's start off with Ultimaker Cura. I'm going to go ahead and open up Ultimaker Cura. If you have your own laptops, you should be able to download this. If you're using a Chromebook from the district, it's likely you're not going to be able to download and install this. We do have this installed on most of these computers here, as well as Bambu. Okay. So if you don't have access to this via your Chromebook, you can always slice on one of these computers here. We also do not have this on a Porto yet. I'm working on it, but you will also not be able to access this on a Porto. Thankfully, this is a pretty quick and painless process. So sometimes I don't even save this sliced file. I just come in, slice, create the G code that I need, and then take it to the 3D printer and 3D print it. And then I just don't even save this file because it's so easy. So here I am, Ultimaker Cura. And when you start off in Ultimaker Cura, one of the first things you need to do is add a printer. And you have two choices to take. Either you're using an Ultimaker printer or a non-Ultimaker printer. So you can actually slice for multiple different 3D printers. I'm not going to do that. I'm going to add a new printer, an Ultimaker printer, and it's going to want you to connect to the Ultimaker wirelessly. We do not have that ability here at the school because of the way the school is set up. We're not each connecting wirelessly to these 3D printers. So I'm not going to sign into Digital Factory, but I'm going to add local printer. And then you would typically look for your printer here and then add it. Or add a non-networked printer, which all of our Ultimakers are, and then find the one that you need. So I'm going to start with S5 and then add that, but I already have it. And the other one is 3 right here. So S5 and 3. Okay, not S3, not just 5, S5 and 3. Those are your two Ultimaker choices. I'm going to close that. And here we are. This is the slicing software. So from here, I'm going to go to File. I'm going to open File to import that STL file. I'm going to navigate, find that file. Thankfully, I organized it into some folders, and I can find it relatively quickly. And there's the file. Can everyone see my coaster? Check on your screens. Do you see my coaster? You see my coaster in the slicing software? No? No? Anybody? No? All right, it's there. It is there. There it is. There it is. So cute. Okay, so why? What happened? If that's the 3D printer and that's the 3, which is the smaller one, why is my coaster itty bitty? Any ideas? Guess. Throw a guess out. Anything. Silly. What do you guys think? Yes. Because what? It is. It's exactly that. All right. Good job. Someone watched the video. So when you bring in your file into usually any slicer, even if you open Rhino and said, I want to make a coaster in inches, the slicers, they don't care. Okay. Most of these CNC laser cutters and 3D printers, they are built to the tolerance of metric units. Does anybody use metric units in this class? No? It's superior. It's better. It's way better than fractions, right? So here in America, we use imperial units, okay, which we don't even have an empire. So I'm not sure why we do. Metric is what's being used all around the world, and it's so much easier. You can have 0.1 of something, you can have 10 of something. To convert from one unit to another, you just multiply by 10 or 100 or 1,000. Here in America, we like quarter inch, eighth inch, 16 inch, 32nd of an inch, 64th of an inch. So the reason why I explain that is because when we're using Rhino, we're working in inches. It's going to bring it in here. And if I said 4-inch in diameter, it actually computes it as 4 millimeters. Okay. And that's why I have such a tiny little coaster. So what do? I need to scale it up. So if I click on it, on the left side, as you can see, everything's in millimeters, and it says 4 millimeters. So X is the width in the X, Y is the width in the Y direction, Z is the thickness or the height in the Z direction. So right now it's giving me a 0.25 millimeter thickness, which is really, really small. So if I navigate to the handy dandy internet and I type in inches to millimeters, inches to mm, and I say I have 4 inches, it's going to tell me, well, you have 101.6 millimeters. So I'm going to copy that. Right click and copy it, navigate back over here, and I'm going to affect either my X or Y. It's a circle, so X and Y are equal. And I'm going to come in here and paste 101.6 millimeters, hit enter, and there is my coaster. That looks way better. Okay, and if you look to the side in percentage, it says 2,540. 254 is the magic number to go from imperial units to metric units. Either you're doing 2.54, 25.4, 2,540, 0.254. So that's your magic number when converting. If you don't like doing math, go to Google. Ask it, hey, what's 4 inches in millimeters? It'll tell you. So that's how you scale that thing up to its proper thickness and width. And the next thing I want to show you is some of our settings. So if I click over here on the right, I get all of my print settings. You get these things called profiles. These are presets that are already determined by Ultimaker on certain settings that work really well. Their naming scheme is based off of the layer height. So layer height is how tall every single layer of your 3D print is. Okay. Now, the shorter the layer height, the finer your 3D print will be, but also the longer it's going to take. So if I look at extra fine, it says 0.06 millimeters. That's super fine. Every single layer is teeny, tiny, barely noticeable. If I look on the other side of the spectrum at fast, if I used fast mode, we have a layer height of 0.2 millimeters. So that's more than 3 times as thick. So it's going to come in, extrude a 0.2 mil size layer over and over again, and it's going to be less layers and therefore less time for printing. So these are all your presets. So if this is something super important to you that you want it to look good after it's 3D printed, I would go for fine or extra fine. If you're just prototyping an idea and you just want a quick idea of what it looks like in reality, and you want to take your Rhino model and put it in your hands, maybe fast would be better, or normal. So I'm going to click on normal. Okay. And then with this 1 and 2, that's telling me, that's describing the 2 different spools of filament that I could have loaded up onto my Ultimaker Cura. So the Ultimaker can hold up to 2 spools, and sometimes I can use 1, sometimes I can use 2. They're interchangeable. Sometimes 2 is just support material, so that way it supports really difficult 3D prints. So you can dictate that by clicking either 1 or 2. It also matters if that is actually loaded up on the printer. Sometimes we only ever have 1 spool loaded up on an Ultimaker, and if you choose 2 and it's sitting on 1, it's not going to do anything because you're requesting that it 3D prints using spool number 2. However, there is no spool number 2. So you're going to have to either move the spool from where it's seated on 1 and move it to 2, or you can come back, slice it for the proper spool number, and go from there. So we have layer heights, we have wall thicknesses, infill densities, infill patterns, which are really interesting. Instead of it just filling your coaster up with 100% density of plastic, we can be super efficient with it and say, well, I don't really need the insides to have like 100% density of plastic. I just want the bottom and the top to show what I've designed. So you might lower the infill density and also use a pattern so that way it's not wasting a bunch of your material. Once you start to purchase your own PLA for 3D printing in the near future, you're going to really care about that kind of stuff because it's money out of your pocket, right? It's like $50 for a spool, and you're going to be very careful with how much you waste. We can generate support material if we have a arching design that requires some supports because it can't just 3D print things up floating in the air. So it could use some support. You can turn that on. And then build plate adhesion. The build plate actually warms up on an Ultimaker. And then you also, just for extra adhesion, use a glue stick on the plate itself to give that first layer good adhesion. Initial adhesion is super important for your 3D prints, which is why when you go to 3D print, you're going to watch that very first layer go down. And you want to make sure that it goes down. If it does not go down and it just starts pooping filament out of the extruder up in the air, you're going to know to cancel that so that way you don't waste your filament. Okay. From there, I'm going to hit slice. Okay. I'm going to close this and I'm going to click on preview. And now I'm looking at a preview of it. If you right click and drag your mouse, you can actually orbit around your coaster. You can zoom in and out with the scroll wheel. But over here off to the right, I have this little scroll bar. And now that the scroll bar is already at the bottom at 1, this is what the very first layer looks like. And as I slowly creep this up, you can see every single layer appear. All that orange that you're looking at on the screen, that is a diagonal infill pattern. So that way the 3D printer is not just putting plastic everywhere. It's doing it super efficiently where it needs to be. If I scroll this all the way up, I'll see that I have 42 layers. It's going to take 42 layers of 3D printing to create my coaster. And this coaster is very small. Down at the bottom, my estimated amount of time of printing is 3 hours and 52 minutes. So that's actually a lot more than I thought it was. Oops, let's undo that. So it's going to take 4 hours on an Ultimaker 3 to create this thing. Now let's say I've sliced it for Ultimaker 3 and then I go over there. Oh, there's no Ultimaker 3s to use. They're all used. I'm going to go back to the Prepare tab. I'm going to select from this drop-down menu Ultimaker S5 and then start the process all over again and slice it. On the S5, it's going to take about the same amount of time, 3 hours and 44 minutes. So let's change normal. Instead of using a normal preset, let's try extra fine. So 3 hours and 44 minutes. Compare that to an extra fine setting, 9 hours and 45 minutes for my little itty bitty coaster. So huge jump in time moving from the extra fine preset to normal. Okay. Now let's look at extra fast. Slice it. 2 hours and 11 minutes, way better. Okay. So if you're doing something like this, an assignment just for my class, going fast or extra fast is totally fine. Okay. Just know that you're going to get less details, right? Let's say I was 3D printing, I 3D modeled myself in Rhino and I was 3D printing it. The thicker the layer height is, the more coarse I'm going to come out. The finer that line is, the more details you're going to see. You know, the curve of my jawline, the earlobes. But if you do it really extra fast, you're just going to get this big blocky 6 foot tall person. All right, so that's slicing. So now we've sliced it. What do we do with that? Save to disk. Usually you will have your flash drive inserted into your computer. Since I don't, I'm just going to save it right here, and then I'll move it to my flash drive later on. You will need to get it on your flash drive in order to put it into the 3D printer for 3D printing. So I'm going to organize it into Coaster, into 3D print. I'll put it right here. Notice that it will name the file automatically for me. It says UMS5 250701 Coaster TJC. It puts that little UMS5 for the Ultimaker S5. And the file type is an Ultimaker format package. It's a very specific G code to go from the slicer to the 3D printer. All right, so I'm going to go ahead and save that here. And then I would put that on my flash drive, run on over to the Makerspace, put this in the S5, get that bed ready, and then we're good. So that's Ultimaker. I'm going to close that. Not even going to save that file. Now I'm going to open up the next slicer, Bambu Studio. I'm going to create a new project. And then for printer, I want to make sure I'm selecting Bambu Lab P1S 0.4 nozzle. If you don't see it, you're going to have to add that printer in, but it's the Bambu Lab P1S 0.4. Okay, please make sure you write that down. Bambu Lab P1S 0.4 nozzle. Okay, so let's go ahead and import my Rhino STL file that I created. File, import 3MF. I'm going to search through my folders to find it. All right away, as soon as I try to import it, I get a dialog box. Object too small. The object from 250701 Coaster TJC.STL is too small and may be in meters or inches. Do you want to scale to millimeters? Yes, I do. Okay, so here's the difference already, right? Bambu Studio was smart enough to know that I probably didn't want to print out a coaster this big, right? It's like, I don't know, that looks pretty tiny, kind of a waste of time. I don't know if I can actually do that. Did you mean it's equivalent in millimeters? Yes, I did. So right off the bat, as soon as I imported it, it's at the right scale. Okay. So when you encounter that, you want to make sure you say, yeah, please scale it up to millimeters. It was in inches. Moving down this dialog box here, we have filament next. So I have 1, 2, 3, 4 different choices. And that's because on our Bambu P1Ss, all of them, we have what's called the AMS. AMS is a device that hosts up to 4 spools of filament. Each of those spools of filament can be fired off into the P1S to complete your print. You can dictate in your 3D model here what gets spool number 1, what gets spool number 2, what gets spool number 3. You can do all of that here. Although they have colors, these colors really don't represent the colors that are actually physically there. Okay, unless this is your own personal P1S and you're synchronizing the colors that are here with what you have in your printer. This is really just kind of arbitrary, more like layer colors. But you also want to make sure that you're using Bambu PLA Basic. Okay. We only use PLA. All right, moving down. In Ultimaker, I have profiles. Here in Bambu, I've got presets. So again, I have an extra fine preset of 0.08 millimeters, but I can go as far down as extra draft, which is 0.28 millimeters. Okay, same concept as using Ultimaker Cura. These are already preset. All the settings are already done. You just need to choose and figure out how clean do I want this to come out, or how fast do I want it to come out. Okay, we've got our layer heights, line widths, seam, wall generator. We can talk about strength. We can talk about speed and supports. You can dictate all of these things here should you not agree with the presets. Once you're happy with it, I'm going to keep it on standard. You can go ahead and slice plate. So I'm going to go ahead and slice plate. All right. And it slices it for me. And it also gives me a complete summary of how much plastic I'm going to use, both in length and in weight. I can input how much that spool of filament cost me, and then it will tell me how much money I'm spending to create this thing. It says 71 cents for this coaster. And it's also telling me how much time it's going to take. So 44 minutes and 15 seconds. So much faster than even the extra fast setting in Ultimaker Cura S5. Cool. So that's that. Now what do we do with this? Well, right here where it says print plate, there's a little arrow next to it. I'm going to click on that arrow. I'm going to say export plate sliced file. Okay. And now I click that button, export plate sliced file. Typically, you would have the memory card in here. So the Bambu P1S uses a tiny little memory card called a micro SD card. So no flash drives on a P1S. And to use that micro SD card, you would need an adapter. I mentioned this in the syllabus. So if you can, it's definitely helpful to own one of those. Let me see if I've got mine here. All right. This is what it looks like. Okay. All right. On the bottom, it accepts both memory cards and micro SD cards. Comes with USB-C connection or USB connection. Okay. Here's the little adapter. It's like a $20 investment. It's super worth it if you want to play with the P1S. Takes the micro SD card and the memory card, USB-C, USB. You guys, takes a little micro SD card from the P1S, and then also takes a memory card, your USB connection, and USB-C. So what you do is you take the micro SD card. There's already a micro SD card at each of the Bambu P1Ss, okay? So you don't need to buy one of those. However, don't lose those memory cards because we also don't have that many extra. But there's no need to keep that memory card. It just stays with the printer. So each one has a micro SD card. You go walk over to that printer, grab the micro SD card, walk on over to your computer, put it inside of here, put this into your computer, and then you take this sliced file or G code, and then you save it. You can save it here in your folders, so that way you can access it later, but you also want to save it onto that micro SD card. Okay. Once you do that, you hit eject, you take this out, you take the little teeny tiny micro SD card out, walk over back to that P1S and put it right in there. Okay. And then you hit go, basically. So that's slicing and that's 3D printing. I'm not going to save this. And then before we get going with the 3D printers, I'm going to show you Easel. So let's move over to CNC. Easel.com/projects. Once you get here, you're going to go ahead and create your own account. They're free. Okay. If it asks you to sign up for premium or pay for anything, there's no need to pay for anything. Just get the free version, you're fine. So I'm going to hit log in. I'm going to click on new project. Okay, so once you guys get to the CNC, what you're going to want to do is I'm going to give you some material so you can make your coaster. Once you get your material, you're going to measure it. You're going to find its center, which I'll show you how to do. And then you're going to come here and input those things. So I know I've already pre-cut some wood for you. It's going to be 6 inches by 6 inches by 1/4 of an inch thick. Okay. And that's a preview of it here in 3D. And then here is what it's going to look like once I get it imported. So I'm going to go back to Rhino. I'm going to go export, type in export. I'm going to select the objects that I want to export and hit enter. I'm going to save this export here in the CNC file. And instead of STL, you're going to look for AutoCAD Drawing Exchange or .dxf. So write that down. For CNC, you're going to export your file, just the one coaster, not all 3 coasters, as a DXF. Yes?
Is that also the same file type for widget print?
Very good. Yes, yes it is. What I want to make sure you don't do is I don't want you to export the 3D model. Okay? It's not going to yield good results. So AutoCAD Drawing Exchange. I'm going to name it. I'm going to give it this name and change this to the date, 25/07/01, A3 coasters, save, okay, and that's it. So I'm going to go back to Easel. Project. Actually, sorry, not project. On the, oh, you can't see it. Let's do that. All right. So on the left-hand side, there is a toolbar, and you'll see the import button. This import button is different than this import button in the project drop-down menu. Okay. If I look at project drop-down, I see import SVG, import G-code, import 3D STL. I don't want any of those. I want the hidden menu of this one. Here I can do SVG, G-code, 3D STL, DXF import 2.0, and image trace. So I want that one. DXF import 2.0. You're going to upload your file. You're going to click on this little plus button. You're going to navigate to where you have that file. You're going to click upload. And there's the little preview. For lines mode, I'm going to let it join it. And basically what happens is it's just a DXF. It's going to import it into here. It's going to actually see a bunch of separate lines. So I'm going to say, yes, please make sure they're joined because I don't want 1,000 lines. I want 1, 2, 3, 4, 5 lines. And then cut path. You could decide whether the cut path is on the path where the CNC's router bit will actually travel on the center line of those lines. Or you could say outside where it'll cut on the outside shape. Or you could say inside where it cuts on the inside shape. I'm going to say on path for now. because realistically, I'm going to change each one anyway, so it doesn't really matter. I'm going to hit import, and there it is. There's my file. I can see through this number grid, it's about 4 inches by 4 inches. Here's my little preview of it. What's the problem with this preview? Why does it look like this? What am I looking at? Point out what's incorrect. Yes, Mia.
X and your rating is gonna go through the.
It's too deep. It's too deep, right? I don't want it to cut those things out. Right? This cutout is okay, right? The outside circle is okay. I want to have a physical coaster like this one here, right? If I don't say cut that circle out, it's just going to leave it in the wood. So that one's okay. But this inner one, currently, if I leave it the way it is now, it's going to cut all the way through. And instead of a 4-inch diameter coaster, I'm going to get a, I think, 3.5-inch diameter coaster. So that's wrong. And then the letters, right? If I leave the settings like this, the letters are additionally going to be see-through and cut out. Again, I don't want that. Right? I don't want to see through the letters because it defeats the purpose of the coaster, right? If I put a drink on top of it and there's got 3 holes in it where my initials are, the moisture's just going to travel right down anyways, okay? So I don't want that. So I need to fix that. Each one of these lines needs to have what it's called its own toolpath, okay? So let's start with the outside one. If I click on that outside circle, I'm going to click on this cut tab, and I can see that the depth at which it's going to cut that outside circle at is 0.25, which is good. I want it to cut, I have 1/4-inch thick material, I want it to cut 0.25. Now cut path, currently it's set to cut on shape path. So the CNC bit is going to travel on the center of that line, which technically is going to be the wrong shape. I want to yield a 4-inch diameter circle. If I say travel on that path, then it's going to be smaller by, it's an 1/8-inch bit, 16th, so an 1/8 inch total. It'll be off by a whole 1/8 of an inch, which is okay, but as a designer, I want to control the output, right? I designed this coaster. It has to be 4 inches in diameter. I'm going to make it 4 inches in diameter, okay? I'm not going to be okay with it being 1/8 of an inch off. That's the standard you want to have as a designer. So what I want to say is cut on the outside of that line. And if it does that, it will produce a 4-inch diameter circle. Let's click on the next line on the interior. This offset should not go 0.25. What's half of 0.25? What? Somebody said something? .125. Okay. When I update the depth of that circle, now I cannot see through it here in this 3D preview. That's good. That's what I'm trying to do. This is basically like the gutter system at your house or home, apartment, whatever it is, right? That's where the water is going to go. Now let's also dictate whether it's cutting on the line, outside of the line, inside of the line. I'm going to say cut on shape path. So I'm going to leave it on cut on shape path. I'm okay with it traveling on the center line of that line. I'm going to select all 3 of these letters. I'm going to hold shift as I do it, and I'm going to change the depth. So let's do 0.125 again. Okay, and then instead of cut on shape path or outside of the shape path or inside of the shape path, let's Let's see what happens if I say clear out pocket. Okay, when you select clear out pocket, it creates a little pocket within that region, and it tries to mill it all out. I want you to notice that here in 2D, based off of my Rhino file, all of my letters have at least 2 instances of sharp corners, right? There's a sharp corner, there's a sharp corner, got a lot of 90-degree corners. If I look at this one, this T, it's rounded. Why is it rounded? Who wants to take a stab at that? Throw something out. Why, when I said, give me straight lines, why does it give me curvy lines? What do you guys think? Somebody shout out something. Yes.
Using the drill?
Yes. This is a CNC, right? It's got a router. Inside of that router is a bit. That bit is spinning, doing revolutions at about 10 to 30,000 RPMs, right? But because it's spinning, you come around all these inside corners, and it's never going to be able to make a sharp corner. And spin it just like that. Which also means that the text or the font that I use is going to be very important. So let's go back to Rhino. And I'm going to do text object. And I'm going to choose a nice, slender, sleek font like Franklin Gothic Medium Condensed. I want to output curves. I'm going to click OK. Nice and skinny, just like that. I'm also going to demonstrate by showing you what a circle with a 1/4-inch diameter looks like. Okay, so the bit looks like this. Actually, it's an 1/8-inch bit. Undo, circle. We'll be using an 1/8-inch bit for this. All right, here's my 1/8-inch bit in plan view. As it goes through, it's spinning and spinning. You see how it will never get to that corner? It'll never straighten that out. But it'll keep on spinning and spinning and coming through here and spinning some more and coming down here. It'll never be able to make a sharp corner. Now let's see what happens when I have a skinny font like this. Okay, uh-oh. My font is skinnier than the bit. Okay, so what's going to happen? Let's see. I'm going to take this out, take this circle out. I'm going to group this if it's not already grouped. I'm going to align it concentrically. And then let's export this. Export. And I'll call it test. Let's come back in here. And let's just add it into this file. DXF import 2.0, upload the file, hit the plus button, find my test file, upload, import. All right, here it is. It's in here. I'm going to take out that circle. I'm going to take out this circle. And I'm going to take out this text, my original text. Oops. All right. So I'm going to select these 3 letters. I'm going to say cut. I'm going to say clear out pocket. Look what it yields. Because the text is too tiny, oops, there's a hidden J back there. Because the text is so skinny and so tiny, even though I'm using a bit that has a diameter of 1/8 of an inch, the text itself is too fine, it's too skinny. So when I have my 1/8 inch bit, this is all it can produce based off what I'm asking it to produce, okay? So when you're CNCing, you may need to thicken up your text by choosing a better font that's fatter, or by enlarging the text so that way you can fit an 1/8 inch circle within there, okay? And just to know for sure, you just come in here to Rhino, use the circle command. The diameter is 1/8 of an inch. You come in here and you test it out. Does this fit? I'm going to put it right in the middle. And I can see already it technically kind of fits, but does not. Okay, so it's going to have an issue doing that whole entire T. It's also going to have an issue doing the top of the T. So if I go back to Easel, yeah, that's why my T looks like that. It really can only do this centerpiece. That's it. And that's why it's showing us that in the preview. Okay, so I'm going to hit undo, 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 undo. All right, so that's what I want to actually output with the CNC. Okay, so I'll show you once we get over there, but we're going to hit Pro, Carve, and then we're going to start to mill it. The thing I want you to know is when you are ready to import this, you can do all of these, make all of these decisions at home. You can make all of these decisions here in class before you actually get to the CNC. Once you get to the CNC, you should have your file ready to go, and you're going to create that coaster. Okay, you don't want to get onto that laptop, start figuring out your depths. You can do all of this at home before you get here. So to do that, you're going to name this project. I'm going to call it coaster, and I'm going to put my initials, and then I'm going to hit close. And the most important thing I want you guys to see, project drop-down menu, share, and then share via link. Make sure you guys write that down. So I'm going to click share via link, and it's going to allow me to share my Easel project with anybody via a link. I'm going to select that link. I'm going to copy it, and then I'm going to put it onto my flash drive. So let me show you how it looks to put it on your flash drive. And put my flash drive in. All right, I'm going to open up my file explorer. Here's my flash drive. I have a folder right here. That's Summer Arc A170 coaster, coaster for CNC. All right, so I need to pick where I want to put it. And here's the thing you really need to focus on. Make sure you write this down. When you're in your file explorer, where your flash drive is, you're going to right click, new, shortcut. Okay. In your flash drive, right click, new, shortcut. We're going to create an internet shortcut and save that internet shortcut here on our flash drive. So in your flash drive, right click, new, shortcut. I'm going to click on that. It's going to give me this dialog box that says, well, can you tell me the location of the item? You're going to paste that shared link from Easel. You're going to click next, and then you're going to give it a name. Link for my coaster 01. TJC, my initials. Finish. So now it's saved on your flash drive, and it's just a link. So here in my flash drive, if I click it, it just opens up this page. That's it. So what we're going to do with that is we're going to put our flash drive into the Makerspace's laptop. We're going to go to Easel. It'll be logged in under the Makerspace's account, which is a premium account. My account is premium as well for educators. And then you're going to open up that link from your flash drive, and it's going to show up on that laptop over there. And then all you got to do is run the file. Okay, so you can do all of this prep that we just did. You can do all of that prep from home, and then with your flash drive, walk over to the CNC, put it in there, and then within minutes, you can start cutting it out. What you don't want to do is get to the CNC, import your DXF, start choosing some file paths and some depths, and spend 30 minutes to an hour doing that when there's people behind you who are ready to go. Okay, so with all three of these machines, be ready to go. All right, are you guys ready to go? Should we go learn how to 3D print and then CNC? Okay, cool. Let's do that. I'm going to eject my flash drive. All right, let's head on over to the print room, and I will show you the 3D printers.